Greetings and welcome to the very first lesson of the Ethereum technology course. In this first lesson, we're going to be taking a high-level overview of what exactly Ethereum is and how it differentiates from Bitcoin technology. Now, Ethereum takes the underlying blockchain technology of Bitcoin and combines that with the Turing-complete scripting language. The term Turing-complete here means a language which is capable of performing any logical step of the computational function. That is, anything which can be expressed in a logical, explicit manner can be encoded onto the Ethereum platform and distilled into some sort of smart contracting agreement. Now, these smart contracts are particularly interesting because they're self-executing and self-enforcing. That is, developers are capable of deciding on predetermined conditions that, when met, these contracts automatically trigger. And this has very large implications for all sorts of finance, insurance, distributed applications, and other use cases that we haven't even begun to comprehend yet. Ethereum is a very interesting technology because it combines the power of Bitcoin technology and creates a platform where developers can use it to create entirely new businesses on what looks like a technology which creates entirely new economic models. Now, similar to Bitcoin, Ethereum is a global, decentralized technology, and it's held in place by thousands of miners, a network of miners across the globe, which are competing to verifying transactions for the incentive of cryptocurrency. And these miners essentially serve to secure and authorize the various transactions that are occurring on the network. Many of those transactions, as we'll see, are smart contracting agreements for distributed computing. Now, one of the interesting ways that Ethereum differentiates from Bitcoin is that Bitcoin is based off of a proof of work hash algorithm. Ethereum, on the other hand, has a slightly different hash algorithm in that it's based on a proof of stake blockchain, which combines with this Turing-complete scripting language. And we'll touch on what exactly it means to be proof of stake in a later lesson. For now, we want to understand that Ethereum takes Bitcoin technology, and rather than using it to go after one specific application of cryptocurrency or one use case, it creates a platform where it is up to the developer to decide what exactly they want to build with this technology. The inventors behind Ethereum, Vitalik Buterin, among others, have mentioned previously that they didn't want to create a technology which had already predetermined use cases, but instead a platform for innovation that developers could use to harness the power of cryptocurrency and the blockchain. And this is exactly what we're seeing with Ethereum. Now, in the way that Bitcoin is structured, we refer to it sometimes as a state transition system. And what this means is that the state of a particular Bitcoin user is how much money is associated with their wallet. And a transition would describe spending or receiving money, or a change in the ownership of money. A similar concept can be distilled in Ethereum, where it is a transition system, except this time it's not just value that is being stored in the blockchain, it is information and legal smart contracts as well. This state transition system in Ethereum is what is being validated by the miners of the network and the underlying infrastructure of the smart contracting system. Ethereum already has seen a very large amount of interest from the developer community, including some blue chip technology firms such as Microsoft, which has already added it to its enterprise Azure platform. Ethereum could be a technology that ushers in an entirely new era of internet-enabled innovation. And in this course, we're going to show you the fundamentals of how this network operates, the economics behind the Ethereum cryptocurrency, and finally, show you how to create your own distributed applications. Thanks for watching, and we'll see you in the next unit.